What is up, math maniacs? Welcome to section 2.1, day 2, represent relations and functions. Let's talk about linear. What's linear? It's a relation or a function that forms a straight line on a graph. So, and then another term you might hear every once in a while is a slope-intercept form. What does that mean? It's y equals mx plus b, where the x is the independent variable and y is dependent on that. So, given an x, you can figure out what a y is. So, let's get some examples of what's linear. So, this first one is in slope-intercept form. Y equals 3x plus 1. Y equals x. That's also, I don't see any numbers there, but it's also a straight line. It's diagonal. Y equals 2, that's a horizontal line like this. And then x equals 3, that's a vertical line. These are all examples of what's linear. Let me show you what's not linear. Y equals 2x squared plus 1, that's just in the shape of a u. It's a parabola. Y equals the absolute value. Here, these lines mean absolute value of x plus 1. That's in the shape of a v. It's not going to be just a straight line on a graph. Y equals 2 divided by x plus 1. It's basically the shape of two different u's, kind of like weirdly diagonally from each other, like that. And then y equals square root of x plus 1, also not linear. It's going to be a sideways u. So let's talk about how we can graph these. So let's say if you're given y equals negative 2x minus 1, we're going to go equation table graph. It looks like this. You can choose 0 if you like. I think 0 is a great number to start out with. Negative 2 times 0 is 0, minus 1 is negative 1. Then go to 1. If you put 1 in for x, the independent variable, you get negative 2 times 1 minus 1, which is negative 3. And you plug in 2, you get y equals negative 2 times 2, which is negative 4. Negative 4 minus 1 is negative 5. You can plot all those points. Each row turns into a point you can plot. So plotting 0, negative 1, and all the other points, it looks like this. You can connect them all, and you do see it's a straight line. You might say, Berg, why do we got to do 3 lines? Why not 2? Well, 2 does actually mathematically define a line. If you have 2 points and you can connect the 2 with a ruler and then draw that graph. For studentship reasons, not for mathematical reasons, just for being a good student and doing whatever you can to make sure you get it right. I like to be a little redundant and go a third row, because every once in a while it does help students catch mistakes. If you see 3 points not exactly in a straight line, then you know you got to check your work again. All right, let's do this again. Very similar. This one's a little bit trickier because first of all, we've got a fraction as a slope, but we can handle it. I'll show you how. And then we have this f parentheses x. Remember, this is function notation. F, the way you read it, the way you pronounce it is f of x. Everyone say f of x. This is not multiplication right here. This is multiplication. You've seen this before. All of you know to distribute this 3 times x and 3 times 1 to get 3x plus 3. There's unwritten multiplication in between the 3 and the parentheses. But confusingly, we've got f and parentheses here. And a lot of people think that this is multiplication, and it's actually not. It's not multiplication. This is how it's called function notation. It's how we write functions. So the different parts of this, when you write this out or when you see it, is first you get the name of the function, which is the f function. It's the name of the function is actually really important when you're talking about lots of different functions. You have to refer to one of them at a time. So it's good to make sure you know what name it is. Then what goes inside the parentheses, again, not multiplication, but this is just how we show what the input is. Right now the input is just x, and we'll specify an input later. And then equals. This is actually not it's not even an equation, really. You can't multiply both sides by 2 or something. No, this symbol lets you know that the rule for figuring out what the output is here. So whatever the input is, you add 1 and then divide by 2. All right. So what does that look like? Here, let's take 0. Again, 0 is an easy number to work with. And what we mean when we write this out is f of 0. You got to say it. F of 0, even if it's strange. What that means is I'm going to take the 0, I'm going to select that as my input and put it into the function. I'm going to write it over here where the rule is, and then that means I'm going to multiply 2/3 times 0, which is 0, plus 1 gives you 1. Now, oftentimes on these equation table graphs, I do like to go 0, 1, 2, which is usually they're often the easiest numbers, but in this case it's not. What you see here, I'm going to choose not to go 0, 1, 2, but I'm going to go 0, 3, 6. And the reason for that is because if I plug in 3 here, I'm actually going to cancel out the fraction, and I won't have to graph any fractions, which is going to be advantageous. It's just going to be easier to not have to graph fractions. So what's 2/3 times 3? The 3's cancel out. I'm just left with a 2. 2 plus 1 is 3. Let's go 6. 0, 3, 6. F of 6, remember this is not multiplication, it's function notation, letting us know that I'm taking 6 as my input, I'm going to put it into the function. The rule says I'm going to multiply 2/3 times 6, which is 4. Kind of hard to see here. It'll be like, if you made this into a fraction, it would be 6 over 1. And then 2 times 6 is 12, divided by 3 is 4. Anyway, you add 1 to it and you get 5. And there it is. You can plot those points, and you can see the slope here is 2/3. We're rising 2 and running 3, rising 2, running 3. And here we're rising 2 and we're running 3. More on that later. Here, the function g says, okay, here's the rule. Whatever the x is, you multiply it by 0.5 and then you add 3. Multiplying by 0.5 is kind of the same thing as dividing by 2, so I think I'm going to choose all even numbers. I plug 0 in. 0 is the input. This is g of 0, says that the output is found when you multiply 0 times 0.5, which is 0, and then you add 3, you get 3. I could go 0, 1, 2, but I think I'm going to go 0, 2, 4. Because when I multiply 1/2 or 0.5 times 2, you just get 1. 1 plus 3 is 4. And then here, g of 4 means 0.5 times 4, and this, which is half of 4 is 2. And then 2 plus 3, you can figure out what that is over there underneath the red dot. But anyway, you can plot the points, connect the lines, and there it is. Let's do just a little bit more. If you ever see y equals 3 and x equals -1, I kind of think it's just easiest to have it memorized. I could explain to you why it is the way it is if you want later, but I'm just going to say that I think it's easiest just to have it memorized. Confusingly, the y-axis is vertical, so you might think that this is the y equals 3 is also a vertical line, but it's not. What you really have to do is you have to go up 3 units. So you start here, and if you want to graph y equals 3, you go up the y-axis 1, 2, 3, and then cross that y-axis here to get y equals 3. Similarly, if you want to graph x equals -1, you go back, you start at 0, and then you go to the left 1 unit for x, where x is equal to -1, and you cross the x-axis. And that's what you graph. All right, y'all. I just wanted to tell you about my favorite restaurant of all time. It's in Guatemala. I lived there for 3 years, and I lived in the capital city, which is kind of like where the airport is and all. But if you take a car ride 4 hours into the mountains, you get to a town called Shela, and there is the most remote Italian restaurant I've ever been to. It's really good food. They have all the pasta and oils and everything imported from Italy, so it really tastes super authentic. And you'd never expect it. It's just a hole-in-the-wall place that you have no idea. Like ask me more about it when we get to class. I'll tell you. Take care, y'all, and I'll see you in class.